Well, hello there. Thanks for tuning into my YouTube channel. And today I want to show you my latest design, which is basically a dual DC motor controller revolving around the DRV8800 from Texas Instruments. Each DRV8800 is a single H-bridge intended for DC motor control. So I packed two of these devices here. You can do two DC motors easily. Now, before I go on and explain what we have here, feel free to go to my website, www.avayan.electronics, that is AVAYAN electronics.com, and in there I have all of the files that you will possibly need to work with this guy. I even include Gerber files. If you want to download the Gerber files and procure your own variable boards, feel free to do so. This is an open source design. All I ask is that you give credit to the guy that made it, which is me, and please don't delete the information such as avayanelectronics.com so that other people can go back and visit the site to get more files and more information as I am continuously updating the website. Now, what do you need to build this board? And let me tell you, you can build this board in 5 minutes if you take a 4-minute nap. It's very, very simple. So what we have here is basically two high current DC motor drivers up to 3 amps. That's the DRV8800 from Texas Instruments. You're gonna have 6 0.1 microfarad ceramic capacitors, 50 volts. They're used for the charge pump and some noise reduction on the BM lines. These are your 3 terminal blocks for connecting high current signals, basically 140 voltage source, which can be anything from 8 volts to 40 volts. And the 2 outputs for motor A and motor B, they're properly labeled with A+, A-, B+, and B-. 1 electrolytic cap, which can be 100 or 220 microfarad, and your header connector, 100 mils separation from pin to pin, containing the control signals for end-sleep, mode, phase, and enable for both motor A and B, and then a ground. Very simple to interface to, very simple to control the motors. I'm going to show you now. Our setup consists of an MSP430 board, which is going to be sending the signals, the control signals, to the dual DRV8800 board, which is then connected to the 2 motors. To turn the motor on, what you need to do is make the signal enable high. If you apply a PWM signal on the enable, you can control the speed of the motor. To control the direction of rotation, you use the phase signal. The mode pin is used to select current decay mode, and this is very important as it chooses how the motor stops. I'm gonna try fast decay first, and you'll see that the motor will coast down. On the other hand, if you use slow decay, the motor will stop very fast. As with a slow decay, you are basically shorting the back EMF, which in turn means 0 speed. It is actually easier to hear that the slow decay is breaking the motor very fast. Alright, this is a demonstration of the dual DRV8800 board, which is called AE-DualDC3A from Avayan Electronics. Feel free to go to my website, www.avayanelectronics.com, and take a look at all the files that I have in there. If you want to place an order for breadboard, that's also another option. Thank you for your time. Have a good day.